In this video, we will take a look at a few literal equations, a couple simplification exercises as if you were working through a quadratic formula exercise, and a couple exercises that deal with solving a quadratic equation by factoring. So you can see on this slide there are two examples here. Both are solving literal equations for some variable. And one big idea you want to keep in mind is that you are trying to get the terms with that variable on one side of the equation and the terms without that variable on the other. So right off the bat, I see this term has t, but this one does not. So I want to subtract p to the other side of this equation. And that leaves me with a minus p equals prt. So now that I have this term with t in it on one side and this term's without t on the other, I can isolate this t a heck of a lot easier. And I can do that by dividing by whatever's left over here, because it's p times r times t. These are being multiplied to t, so I'm just going to divide them away over pr over pr. And that leaves me with t equals a minus p over pr. Right, this p reduces away, this r reduces away, just leaving me with t. And so I just wrote this equality in the reverse order, which is allowable. So there's the answer. T equals a minus p all over pr. In this next example, we don't have that access to c. We would have to first distribute this 1/2 h to b and to c before we can start moving terms from the left to the right or from the right to the left. But even before that, this is concerning to me. I do not want to have this fraction in my equation. So as you may have guessed, you can use an LCD here. And luckily, there's just this one denominator, so I know the LCD here will be 2. So I'm going to multiply each term by 2. And you might be wondering, well, I see 2 terms here. This is b plus c. A term is separated by plus and minus signs, correct, but this whole side here is one term because this plus sign is inside a set of parentheses. So inside this set of parentheses, there are 2 terms, but since there's no other plus or minus sign outside of parentheses, this is all one term. And that's how you can eliminate the 2 here. So this leaves you with 2a equals h times b plus c. Now there's always more than one way, usually more than one way, to solve an equation. And I'm going to choose to distribute the h here. So I've got 2a equals hb plus hc. Keep in mind we're solving for c. And now we're back to that big idea. We have all these different terms here. I want all of the terms with a c on this side and all the terms without a c on the other. So I'm going to subtract hb. And so on the left side now, I have 2a minus hb equals hc. And then I'm back to where I started with this h is being multiplied to the c, so if I want to get rid of that h, I can divide it. That turns into 1, so all of this is now over h. And I'm left with c equals 2a minus hb all over h. And there is an answer. In this example, we need to solve for p. Now, sometimes the variable you're solving for is in more than one term. That is what's happening here. So you cannot just say, oh, I'm going to subtract PRT from both sides and get A equals A minus PRT equals P. Say, hey, I solved for P. P is isolated. But is it really? You didn't isolate P. There's a P on the other side of the equation. So if you see terms in more than one term containing the variable you want, you have to do something else. So this work is no good. So you have to do something else. What do we need to do? Well, we need to make these two p's somehow turn into one p. And that is going to be done by common factoring. So what that means is you are going to divide each of these terms by p. So I'm going to rewrite the equation down here, p plus PRT. So I'm going to divide this by p, I'm going to divide this by p, and I'm going to get A equals, well, p divided by p is 1. These p's will cancel, plus RT. Great, we divided away the p, but now in this equation we don't even have a p. So we kick the p we divided to the front. And you can see if you multiply this p to the 1, you get p, back up here where we started. If you multiply this p to the RT, you get PRT, just like what we started with. So common factoring out the p means that the p has to be a part of our factoring. And look at that, we only have one p now. This is A equals P times this whole thing over here. So if you're trying to isolate that P, we can just divide by that whole thing right there, 1 plus RT. And we can get, so this reduces to 1, that whole thing. And so we get P equals A over 1 plus RT. And there's the answer. And in this final example, solve for this equation for x, you may notice that this is rational. We have variables in the denominator. On the last slide, there was just a 2 in the denominator. So the fact that we have variables here means this is a rational equation, and we need to solve for x. So again, since it's rational, or we have things in the denominator, we should probably find an LCD. So the LCD here, luckily, is pretty easy to find. It's just going to be x and y. We need to eliminate an x in the denominator, so I know x has to be in the LCD. And we need to eliminate a y in the denominator, so y needs to be a part of the LCD. So multiply each term by xy. And we get this resulting equation. Y plus x equals bxy. Again, important to keep in mind which variable you're solving for, in this case x. And you'll notice that there's an x on the left and an x on the right. And that doesn't work out very well. Right over here, we had both, or all terms with p on the right, and all the terms without p on the left. So the first thing we need to do is move this term to the right side of the equation. And so that'll be subtracting x, that'll turn into 0, minus x. And so this will now look like y equals bxy minus x. And now this situation is very similar to this one. There's more than one term that has the variable I want. So what do we get to do? We just get to divide each term by that variable. That is a common factor. Each term shares that x. So what happens is that common factor gets kicked out to the front. We're actually going to divide these things now. This is 1. And we get by minus 1. And now you may notice that x is being multiplied by this thing. So we can say divide by that by minus 1 on both sides. Very similar to what was happening right here. It was the variable we want times something, divide by that thing. So we end up with x equals y over by minus 1. Simplify and write in standard form. So most of the simplification that you see with these two exercises is just knowing how to reduce a radical, and more specifically a square root, and knowing how to write in standard form, which means reducing fractions. We'll get to standard form. I will mention when we get to standard form when we get there. It's just a fancy name for splitting fractions. So we can take a look here. The first thing I want to do with this expression is simplify the square root. So over here off to the right, I'm going to write the square root of negative 45. And really the first thing I want to do is get rid of this negative. I want to turn that into the I, and that's because the negative is on the inside of the square root, multiplied to the 45. So that leaves me with a 45 left over inside the square root. And I know that the 45 can be broken down into square root of 9 times square root of 5. One of these square roots I can easily take the square root of, and the other one I can't. I don't know what the square root of 5 is, but I know what the square root of 9 is. The square root of 9 is 3. So I'm going to have the I trail the whole number, because that just feels right. Even though I is not a constant, I means square root of negative 1. That's why the negative here turned into an I. So that feels right, 3i. You would normally say 3x if this were an x. But then the square root of 5 would go behind the I. And that's just a notational thing that I do to make sure that nothing is listed after the square root, just to make sure you all know that the I and the 3 are not in the square root. It just saves a lot of confusion. So what do I do with this? I replace this square root of 45 with 3i square root of 5. So it's going to look something like this. So the entirety of this square root gets replaced with 3i square root of 5. So that's the first bit of simplification. The last bit of simplification is when we start talking about standard form. And all that really means is you take this negative 6, you put it over 12. Whatever sign is between these two terms ends up between the fractions. And this ends up being 3i square root of 5 over 12. We're just taking each term in the numerator and giving it the denominator 12. And this only works like this because there's one term in the denominator. So now all we have to do is simplify this. 6 over 12 is the same thing as 1 over 2, and it's negative. So the final answer here is going to be 1 over 2 minus 3 over 12 is the same thing as 1 over 4. I'm not going to write the 1, so it'll be I square root of 5 over 4. And you might be wondering, why doesn't the 5 simplify with the 12 at all? Well, first of all, 5 doesn't simplify with 12. But secondly, you do not simplify numbers inside of a square root with numbers that are outside of the square root. You only simplify numbers that are outside of square roots. So the 3 over the 12 only. And this is the answer. I'm going to stop talking for a few seconds so you can have a chance to pause the video and try this one for yourself. After I go silent, I'll leave about 5 seconds, and then if you let the video go, the rest of the solution will appear for this. So here is the rest of the solution for simplifying this. And again, the first step is to simplify the square root. I ended up with 6i squared of 2. Plug that in for this entire square root, so negative 18 minus, boom, that whole square root gets replaced with what's in pink, all over 42. Split it into two fractions. Each fraction gets the 42 in the denominator. Simplify each fraction. This is what you end up with. On this last slide, these last two examples here, you are asked to solve the following equations. And these equations are slightly different from any equations that you may have seen already, at least in this video. And that is by the fact that these are quadratic equations. And you can tell they're quadratic because the highest power of x is squared. And over here, you can't quite tell yet, but the highest power of t will be 2, or t squared. So, what your first defense in solving quadratic equations is finding a GCF, or a greatest common factor. And those are generally easy enough to spot. Something like you can divide all these numbers here by another number. So 2, 3, 4, 5. Something that's just not 1. Another thing that you might notice is that each term would have the same variable, like in this example, x. But they don't all have an x. And you can't divide 6 by anything. Well, certainly you can't divide 6 by 17, but you can't divide 17 by 6 or any factor of 6. So there's no GCF here. What you want to do next is to run through a little checklist about the methods you know for solving quadratics. The first and the most efficient way would be to solve a quadratic equation by factoring. And if you're trying to factor, you will need to know what a, b, and c are. And a, b, and c will always be in the right order as long as you have the powers of x in descending order. So you start with the highest power of x in the first term, so x squared. Here in the second term, there's an x to the first power. We don't write the 1 there. It's understood to be there. And in this last term, there are no x's. So 2, 1, 0. That's descending order. So you can find a, b, and c pretty easily. And what we need to do is we need to figure out two numbers that multiply together to give you the number you get when you multiply a times c. So a times c is 72. So I'm looking for two numbers that multiply to give me 72. And those same two numbers need to add up to give me b. Right? It's important to identify all three values. So we're going to use them in this little table over here. b is negative 17. So you can think and think and think and think and think. And eventually you'll arrive at the fact that 8 times 9 gives you 72, and 8 plus 9 gives you positive 17, but we need a negative 17. So switching all the signs to negative 8 and negative 9 Well, this still holds over here. Negative times negative is positive 72. Negative plus a negative will stay negative. So we need a negative 8 times a negative 9, and those two numbers will also add up to 17. So how is this helpful? Well, I'm going to rewrite the entire equation again. 17x plus 12 equals 0. And what we do is we split this minus 17x into these two numbers. So negative 17x will turn into negative 8x minus 9x. And the first term and the last term still come down for the ride. 6x squared plus 12 equals 0. So all we did was split this one term up into two. Now we have a very nice breakdown that allows us to do factor by grouping. So I can group up these first two and find a common factor, not of all four terms at once, but just these first two. And it turns out the common factor here will be 2x, because each number can be divided by 2, and each term has an x. So to figure out what goes inside here, we just have to make this division. This is 3x minus 4. Now in these last two terms, we also need to find a common factor. Again, not of all four terms at once, but no, just these last two terms. And something I did not mention over here is that whatever common factor you have will share the same sign with the first term. So since this is a positive 6, we have a positive 2x common factor. So when we look at these two, the first term is a negative 9x, so that's negative. So when I tell you the common factor, both of these numbers can be divided by 3, we're not going to divide them by 3, we're going to divide them by a negative 3. That's because the common factor shares the sign with the first term. So this ends up being negative 3 times, 3x minus 4. And if everything is going to work out nicely, then these sets of parentheses should match. And they do. So now we only have two terms. And again, that is because this is the only addition or subtraction that is happening outside of parentheses. So all of it before that is one term, all of this after is another term. Each term has this 3x minus 4 in common. So 3x minus 4 is a common factor. What's left when we get rid of this 3x minus 4 is 2x minus 3. And that equals 0. So now that we've done all the factoring, we can actually go ahead and solve this. We can take each term, or each factor, so 3x minus 4 and 2x minus 3, and we can set each one individually equal to 0, and we can solve for x. One thing I want to point out is that these little equations here are a heck of a lot easier to solve than looking at this original equation and trying to substitute some numbers in for x until you can make this left side equal 0. This right here, like just guessing, that would take you a very long time. In fact, probably even longer than a very long time, because when you solve these equations, you're going to end up with fractions. And most students' guesses are not involving fractions. So, what tool allowed us to get from this scary looking equation all the way down here into some manageable equations to solve? Factoring. I always tell students you don't have to like factoring, but if you're going to be in math classes, you need to be good at it. This skill will keep popping up over and over and over and over. Anyway, finally, let's get to solving these. The final answers here, if you solve these for x, will be x equals 4 over 3 and x equals 3 over 2. So you can have more than one answer. And in fact, you can have up to 2 answers, that 2 coming from the biggest exponent of x. So I promise in this last example here, everything will go by much quicker. The only difference between this example and this example is that you don't have this equal 0. We need this before we can start factoring. So first step, we're going to distribute the 2t to everything there and get 4t squared plus 2t. And then I'm going to distribute the negative 3 here to get negative 6t minus 3 equals 5. Combine these two together to get 4t squared minus 4t minus 3 equals 5. And then since we need this equal 0 here before we can start factoring, subtract 5, subtract 5. This is 4t squared minus 4t minus 8 equals 0. This particular quadratic equation does have a common factor, and that common factor is 4. Again, the common factor will share the same sign with the first term as long as everything is in descending order. So that common factor will come out to the front, and everything that's left over will be what you get when you divide everything by 4. So t squared minus t minus 2. So you can go through this process here to factor what's left inside the parentheses to end up with 4 times t plus 1 times t minus 2 equals 0. So then from here we can take each factor that has a variable, so t plus 1 and t minus 2, and set it equal to 0 and solve for x. Solve for t. Eventually getting you to the answers of t equals negative 1 and t equals a positive 2.